Now I want you to take a look at this car that I'm holding here. You see this car, I'm going to use it to illustrate this question that we have here on the board so that you understand exactly what is happening in this place. So let's read the question so that you know exactly what is happening before we illustrate it. Now the question says that a car with an initial velocity of 20 meters per second is subjected to a uniform deceleration of 2 meters per second square. The time taken to bring the car to a complete halt is... Now, let's illustrate what this question is trying to say. Now, this is the car. They say a car. This is the car. With an initial velocity of 20 meters per second. What this means is that this car is moving very fast. 20 meters per second means that for every 1 second, this car moves for 20 meters. So it's moving very fast. For every 1 second, this car can move for 20 meters. 20 meters is somehow very fast. So for every 1 second, this car moves for 20 meters. And then as this car is moving very fast, is now subjected to a uniform deceleration of 2 meters per second. So what this means is that as this car is moving very fast, then all of a sudden, the driver maybe actually match the brake and it begins to slow down the car from fast. He was moving fast before. From fast, he's now reducing his speed until he reached a place where he will now stop. So he was moving very fast, then all of a sudden, he slowed down until he stopped. So that's what the car is telling you. So now, let's see from the time now that the car is moving fast to the time it will stop. What is the total time it will take? From the moment this car begin to slow down its speed and stop, what is the time that is going to take? That's exactly what the question is asking us. Okay, so now that you have understand what is happening in this question, let's solve it so that we can see what is the time that is going to take for this car to stop from the time it was speeding. So first we'll write solution. Now, first thing we need to do is to bring out what we have been given from the question. So you can see that we have an initial velocity. Initial velocity is given as u is equals to, we have that is given as 20 meters per second. That's the initial velocity. Now, again, we see that a car is subjected to uniform deceleration. So this is an acceleration, but this time around, because you are reducing this acceleration, you are reducing your speed. You are not speeding, you are reducing the car speed. You know, the car is moving fast before. So now you are reducing your speed until you stop. So this acceleration is going to be negative. So it's negative 2 meters per second square. So anytime you hear deceleration, it means negative acceleration. Because this time around you are reducing your speed, you are not increasing your speed, alright? So another thing we need to know from this question is that this car started with an initial velocity of 20 meters per second, but as it moving, it now come and stop. So that means the final velocity, that is v, is going to be 0, because as you are moving fast, you will now come and stop. So the final velocity with the car will end with is 0. So that's why we have v is equals to 0. And what we are asked to find is t, time. That's what we don't know. So let's find a formula that we can use to find this thing. So from this data we have been given, we can use this formula. It's given as v is equals to u plus at. This is the first equation of motion. We call it the first equation of motion. So with this we can be able to find out the time that we are asked to calculate. So what is our v? V is given as 0, while u, initial velocity, is given as 20 meters. So we write 20 plus acceleration is negative 2. So we write negative 2 times t. We don't know t, so t is what we are asked to find. So from here we have 0 now is equals to 20. So we have minus 2t, minus 2 times t is going to be minus 2t. So this minus is going to affect this plus, and we are going to have minus 2t here now. Exactly. So what we want to do is to make 2t subject a formula. So if we want to make 2t, we'll bring it to this other side of the equation. And by the time we carry this 2t and bring it to this other side, the negative sign is going to change to plus, because anytime you carry a number or a sign and cross it to the other side of the equation, if it was plus, if it comes to this side, it's going to be minus. But now that it's minus, the moment we carry this 6 and bring it to this other side, it's going to turn to plus. So what we'll have here is going to be 2t is equals to So here we'll be left with only 20. So from here we want to make t-solid formula, so we'll divide both sides by 2. So we'll have divide both sides by 2. So t will cancel t, and then what we'll have left is t is equals to 20 divided by 2. So 20 divided by 2 is going to give us 10. So that means our answer is 10, and the unit of time is second. So the time it takes for this car to come to a stop is just 10 seconds for this car to stop. As it's moving very fast, for it to come to a stop, it will just take 10 seconds. Hope you understand.